Hello, hi everyone. Welcome to the student brand. This is your Siva sir. Today we are going to discuss about light reflection and refraction. Light reflection and refraction. Okay, so let's start the topic. Let's start the topic. So light is a form of energy which gives the sensation of sight. Light is a form of energy which gives the sensation of sight. Understood? I hope it is very clear. Light is a form of energy which gives the sensation of sight. Sensation of sight. So when light falls on it, so it reflects back. It reflects back. The bouncing back of the light from the reflecting surface is called reflection of light. The bouncing back of the light from the reflecting surface is called reflection of light. The bouncing back of the light from the reflecting surface is called reflection of light. Understood? The light ray incident on it, it reflects back. It reflects back. Let's start. Light reflection and refraction. Light reflection and refraction. Light reflection and refraction. Reflection and refraction. Refraction. Okay, so when light is incidenting on the surface, so this is a plane mirror. So plane mirror is nothing but, so one side is reflecting surface, another side is silver coated. One side is reflecting surface, another side is coated. One side is reflecting surface, another side is coated. Okay, so plane mirror I'm taking. The bouncing back of the light from the reflecting surface is called reflection of light. The bouncing back of the light from the reflecting surface is called reflection of light. So I am taking this the incident ray, and this is the reflected ray, and the light which is perpendicular to the plane surface is called normal line. The light ray which is perpendicular to the plane surface is called normal line. Okay, so the light ray which is perpendicular to the plane surface is called normal line. Understood? So the bouncing back of the light from the reflecting surface, the bouncing back of the light from the reflecting surface is called reflection of light. The bouncing back of the light from the reflecting surface is called reflection of light. Reflection of light. Understood? Is it clear? Yes or no? So the bouncing back of the light from the reflecting surface is called reflection of light. Incident ray, reflected ray, normal line. Incident ray, reflected ray, and incident ray, reflected ray, incident ray, and this is the normal. The angle between incident ray and normal line is angle of incident, angle between reflected ray and normal line is called angle of reflection. Angle between incident ray and normal line is called angle of incidence. Angle between reflected ray and normal line is called angle of reflection. Angle of reflection. And this the light ray, so which is actually that is the undeviated line. So that is the undeviated line. So you can see here this undeviated line or initial direction of the incident ray. Initial direction of the incident ray. Understood? This initial direction of the incident ray. So the angle between reflected ray and undeviated line is called angle of deviation. So reflected ray and undeviated line. Undeviated line is called, what is that? Angle of deviation. Angle of deviation. So now you can see the angle that is 180 degrees. That is 180 degrees. Linear angle is 180 degrees. Linear angle is 180 degrees. I hope it is very clear. So How much is the linear angle? 180 degrees. So that is include of angle of incidence plus angle of reflection plus angle of deviation. That is including of angle of incidence plus angle of reflection plus angle of deviation. Okay, sorry for that. So angle of deviation. Okay. Yes. All right. Chalo. So laws of reflection. I'll explain about laws of reflection. Based on this one, we will discuss about problems. Based on this one, we will discuss about problems. Laws of reflection. Okay, laws of reflection. So point number 1, incident ray, reflected ray, normal line lies on the same plane. Incident ray, reflected ray, normal line. Incident ray, reflected ray, normal line lies on the same plane. Point number 1. Coming to the point number 2. Angle of incidence is equal to angle of reflection. Angle of incidence is equal to angle of reflection. Understood? So angle of incidence is equal to angle of reflection. Once again, observe carefully here. So here, incident ray, reflected ray, normal line, angle between incident ray and normal line is called angle of incidence. Angle between reflected ray and normal line is called angle of reflection. Angle between reflected ray and undeviated line or initial direction of the incident ray. Initial direction of the incident ray or undeviated line is called angle of deviation. So linear angle is 180 degrees. That is include of angle of incidence plus angle of reflection plus angle of deviation. Okay, coming to the laws of reflection. So laws of reflection. Coming to laws of reflection. Incident ray, reflected ray, normal line. So incident ray, reflected ray, normal line lies on the same plane. And second one, angle of incidence is equal to angle of reflection. Angle of incidence is equal to angle of reflection. So actually, whatever I am discussing, based on that, questions will come. So these are important topics only. So everything is important, but so where we need to concentrate. So what type of topics they will give in exam, that is very important. We need to focus on it. Okay, so here you can observe. So laws of incident ray, reflected and normal line. Angle of incidence is equal to angle of reflection. So here you can observe. So the linear angle including of angle of incidence plus angle of reflection plus angle of deviation equal to 180 degrees. Angle of incidence plus angle of reflection plus angle of deviation equal to 180 degrees. Understood? From coming to laws of reflection, angle of incidence is equal to angle of reflection. From laws of reflection, angle of incidence is equal to angle of reflection. So from that, angle of incidence plus angle of deviation equal to 180 degrees. So that is equal to angle of deviation equal to 180 minus 2 angle of incidence. And angle of deviation equal to 180 minus 2 angle of reflection. So I will ask one question. If the light ray is passing along the normal line, what is the angle of incidence and what is the angle of reflection and what is the angle of deviation? So if the light ray passes along the normal line, what is the angle of incidence and what is the angle of reflection? So if the light ray passes along the normal line, what is the angle of incidence and what is the angle of reflection and what is the angle of deviation? So let me know. Let me know in the comment section. If the light ray passes along the normal line, okay. So along the normal line, not with the degree. So if you are taking here, so if light ray passes along the normal line, what is the angle of incidence? First one, and coming to the next one, angle of reflection, and third one, what is the angle of deviation? So let me know the answer. So anyone knows the answer? So if the light ray passes along the normal line, What is the angle of incidence, what is the angle of reflection, and what is the angle of deviation? So anyone knows the answer? Just let me know those who know the answer. If the light ray passes along the normal line, if the light ray passes along the normal, what is the angle of incidence, what is the angle of reflection, what is the angle of deviation? So if you want to, okay, if you want to tell the answer to this question, first of all you have to know that angle of incidence definition, angle of reflection, and angle of deviation. And then only you can tell the answer. So the angle between incident ray and normal line, that is called angle of incidence. Angle between reflected ray and normal line is called angle of reflection. Angle between reflected ray and undeviated line is called angle of deviation. So angle of incidence is 0. Angle of reflection is 0. Angle of deviation equal to 180 degrees. How can you say that? How can you say that? Because, so what is the angle of incident? Angle between incident ray and normal line. So incident ray is there only, normal line also in the same direction. So that's why angle of incidence is 0. And coming to angle of reflection, angle between reflected ray and normal line. So reflected ray in the same direction along the normal. So no angle. So 0. Coming to angle of deviation, angle between reflected ray and undeviated line. Initial direction of the incident is like this. So that angle is called angle of deviation, that is 180 degrees. That is a linear angle. Understood? So if you want to identify these angles, so you must know the definition of angle of incidence, angle of reflection, and angle of deviation. Understood? So next one. So example for regular reflection and irregular reflection. Those who knows the answer for examples of where regular reflection takes place. Anyone knows the answer? So on which places regular reflection takes place? So now we will ask the questions as well as, so now I will ask the questions. So actually this CBSE grade 10 physics, I am teaching 4 chapters: light, reflection and diffraction, human eye and colorful world, magnetic effects of electric current, and electricity. So these 4 chapters. Once check the previous live classes, you will get to know. Okay. So these 4 chapters vigorously. So before we are given practice for electricity problems also. Electricity problems also we practiced in the previous live class. Okay. Once check the previous live class. Before that, so we discussed about human eye diagrams, everything. Before that, so light refraction, like that one by one we are coming. Okay, and next to the live class I will discuss about magnetic effects of electric current. Magnetic effects of electric current. So live classes will continue. Okay, so throughout the day live classes will continue. You can join to the live class. Click on like button. So click on like button. So click on subscribe button and click on bell icon. You'll get the notifications whenever I'm taking the classes. And which topics. So I'll mention the topic also, which topic I'm taking classes. So that time you can attend the classes. So I'll mention the topic name. And so throughout the day, so classes will be going on. So approximately timing I will tell. So morning around 10 o'clock. So after that, immediately it will go 3. After that it goes 6. After that it goes like around 9:30 or 10. So like that, sometimes it may vary, but appropriate timings I am saying. These are appropriate timings. So around 10 o'clock I will start morning time. After that it goes until 1, 2 like that. Again 3 o'clock class. So after that again 6 o'clock. So around 6 o'clock I will start. So like that, as I said, appropriate time. So తెలుగులో కూడా వీడియోస్ చేయొచ్చు, బట్ ఆల్రెడీ చేస్తున్నాను. సో కొన్ని వీడియోస్ అయితే, సో నార్మల్గా ఫ్యూ లైవ్ క్లాసెస్ తెలుగులోనే చెప్తున్నాను, బట్ నవ్ ఆల్సో ఐ విల్ డూ. ఓకే, yes, so it will be helpful for CBSE grade 10 students, right? That's why I'm taking. So overall, so for everyone, that's why. Now I'll teach few classes. So coming up, I'll take classes on remaining chapters, remaining also. So I'm planning. So definitely I will take classes. So I'll continue the classes. Okay. So just do like, share and subscribe and share to your friends. Ask your friends to join to the class. Those who are studying 10th class, because now exams are going on. So now coming up exams are there from 17th onwards. So that's why. So vigorously we need to work out now 10th. So hardly few days left, only 1 week. 1 week only. 1 week only there. So that's why I'm taking classes now. So very seriously, sincerely. So that's why. That's right. Okay, so that's why I'm taking classes. So definitely I'll take in coming up. I'll take remaining also. Okay. So do like, share, and subscribe to Student the Brand if you like the content, if you like the channel, if you like my explanation. Then come to the point. So I'm good. Brahmananga unnam, Bivatsanga unnam. Do you teach SS? Yes. So I'll teach SSC also. I'll teach. Oh, thank you. So I already thought. So state board also I thought, and the CBSE also thought. So that's why. So I'm taking two class. So two. I'll start as I said. So now it's going on. So I'll work on it. Definitely in coming up classes. So you'll get it. Oh, great. Yes, few topics. See, SSC also few topics are related here. So to this only. Okay. So maximum topics are comparable only: light reflection, diffraction, human and color fluid. So magnetic effects of electric current, electricity. All are related only. All are related. Few topics vary. Okay. Few topics vary. I can understand. Those topics we need to work out. So if you listen this class also, so it will be helpful to you. Okay. So almost 70 to 80% almost it's same. So only the 20% difference will be there. So here and there, those points I have to know. ಸ್ವಲ್ಪ ಗೊತ್ತು. ಸೊ ಚೆನ್ನಾಗಿದ್ರಾ ಆಯುಷ್? ಯು ಕ್ಯಾನ್ ಲಿಸನ್, ನೋ ಪ್ರಾಬ್ಲಮ್. ನಮ್ಗೆ ಗೊತ್ತು, but to speak so a little I know. Yeah, so I'm good. I can understand. So when you speak I can understand, but to speak so fluently, because words we need to frame in mind, then only I have to speak. Because okay, for converting the words to there, it takes. Okay, so from Hyderabad. Okay, done. So come to the point. Let's start. Okay, so you can listen. Those who are studying SCC also you can listen. One, check those videos and check the topics. So similar ones only, maximum similar ones. So here and there you have to, okay na? So compare the topics. That's enough. Nothing else. So I thought to the SSC students also. Okay, so like that. That's enough. Both the streams I thought. So SSC and CBSE and ICSE also, to ICSE students also I thought. Okay, so to everyone, maximum all boards. So few which are there available around me, those boards I thought. And still so many boards are there, so we'll work out. Okay, done. So coming up 11th and 12th, so those classes I'm starting. Okay, so that also. So 11th physics and MSET students also you can join. NEET, JEE. Okay, so those students also can join, attend the classes. Okay, so you can do like, share and click on like button and click on bell icon. Then you'll get notifications whenever I'm taking classes. So be aware of the classes, then automatically you'll get it. Okay, so let's start. Now you can see. So regular reflection. So I'll ask two questions. So where regular reflection takes place? Yes. So you want to know this? No, you wanted to know about the costume. So once go and check the videos. Once go and check the videos of my channel, so you will get to know. You will get to know why I'm like this. So I hope you'll get to know. So my entire channel, so right from starting onwards, there are many experiments, many things. Okay, so related content is physics only, but so the way of expressing, the way of, okay na, getting up ready, so it's a different completely. So once go and check, so you'll get to know. Check the videos. If you like the channel, if you like the content, if you like my explanation, please share to your friends, ask your friends to join to the class. Okay, so share as much as possible, as many as possible. Please support the channel. Thank you. Right, so now, yes, so regular reflection takes place on a smooth surface. So I'm taking, these are incident light rays, incident light rays, incident light rays, incident light rays. After reflection, those light rays are no. After reflection, those light rays are also parallel. Okay, incident light rays are parallel. Then reflector light rays are also parallel to each other. So incident light rays are parallel. Then reflector light rays are also parallel to each other. This type of reflection is called regular reflection. Regular reflection. Understood? So here you can see incident light rays are parallel, then reflector light rays are also parallel to each other. This type of reflection is called regular reflection. Regular reflection. Regular reflection. Coming to irregular reflection. Irregular reflection. So you can see here. You can see here. So incident light rays are parallel. Incident light rays are parallel, but reflector light rays are not parallel to each other. Incident light rays are parallel, but reflector light rays are not parallel to each other. Understood? So the type of reflection is called irregular reflection. So 1, 2, and 3, and 4. Okay, so these light rays, so you can see here. So here, incident light rays are parallel, but reflector light rays are not parallel to each other. Incident light rays are parallel, but reflector light rays are not parallel to each other. So this type of reflection is called irregular reflection. Irregular reflection. Understood? Regular reflection and irregular reflection. So can anyone say the example? Irregular reflection. So where regular reflection takes place? Examples. Anyone knows the examples of regular reflection? Regular reflection and irregular reflection. Regular reflection. Second point is irregular reflection. Irregular reflection. Irregular reflection. Can anyone says? Can anyone knows the answer? Okay. So can anyone says regular reflection and irregular reflection? Irregular reflection. Irregular reflection. Examples. Anyone knows the example? Regular reflection is mirror. Okay, plane mirror. You can say plane mirror. Very good. Next one. Any other examples? Any other examples? Anyone knows the answer? Just type in the comment section. So regular reflection. Example for regular reflection. Example for irregular reflection. So I'll give you some time. Okay. Next. Regular reflection and irregular reflection example. So I'll count 5. After 5, I'll go to the next topic. So those who know the answer, you can tell 1, 2, 3, 4, 5. Okay, then next one. So we can go to the next one, that is object and image. Object and image. Object and image. So real object. So which are light rays related? Real object related to real object. Okay, real object. real image, we can say real image related to first one. Real image related to reflector light rays or reflector light rays. Reflector light rays or incident light rays. So incident light rays. Incident light rays. Incident light rays. So answer, real image related to option number 1 or 2. So just to comment 1 or 2. 1 or 2. So real image related to reflector light rays or incident light rays. Can I know the answer? So comment 1 or 2, just type those. So no need to type real, reflected or incident. Just to type 1 or 2. 1 or 2. So just you can type any one option. Any one option you can type. So I'll give time, right? So I'll give time. So my name is Siva sir. Okay. So I'll give time. I'll count 5 counts. So those who know the answer, you can comment in the comment section. 1 or 2. So type any one option. Any one option. Real image is related to. Real image is related to. Real image. Those who already answered, so no problem, no need to answer. Remaining students, you can answer to this question. So I'll count. I'll count. Ready? So answer to the question. So which option? So real image related to. Real image related to. So reflector light rays or incident light rays. So next topic is related to this one. Next topic is related to this one. Ready? 1, 2, 3, 4, 5. Okay, let's start the topic. So next one, you can see here, object I am taking. So here you can see, this is a plane mirror. This is a plane mirror. Understood? So here you can see, light rays are coming from the source. Light rays are coming from the source. After reflection, those light rays are meeting here. After reflection. So what is this one? Real image. Real image. If you are extending the incident light rays, so here, these are incident light rays, that is a virtual object. Virtual object. The point of intersection of okay. So here you can observe the point of intersection of reflector light rays. So reflector light rays are meeting directly. So their image is forming, that is a real image. The point of intersection of extended incident light rays. So incident light rays, extended incident light rays are meeting at one point. That is a virtual object. Virtual object and real image. Virtual object and real image. So next one I will draw so you can observe. So this is the object, from here this is a real object, from here light rays are coming. After reflection, those light rays are moving away from it. After reflection, those light rays are moving away from it. If you are extending those light rays, so what is this image? What is this image? Can anyone say? So what is this image? Real image or virtual image? Real image or virtual image? So what about this image? Real image or virtual 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 image? I'll give time. 1, 2, 3, 4, 5. Very good. So this is a virtual image. The point of intersection of extended reflector light rays. So we are extending this reflector light rays. Extended reflector light rays are meeting at one point. Extended reflector light rays are meeting at one point. Their image is forming. That is virtual image. And here you can see the point of intersection of reflector light rays. Directly reflector light rays are meeting at one point. There is a real image. So here virtual object. Here virtual image and real object. So we can conclude that object is real. If object and image, object is real. What about image? Object is real. What about image? Object is real. What about image? Anyone knows the answer? Let me know the answer. So fill the box. Object is real. What about image? Virtual or real again? So by conclude this, by observing these two diagrams, what about image? Object is real. What about image? Observe the two diagrams. Observe these two diagrams, you can get to know. Observe these two diagrams. Object is real. What about image? Virtual. Object is virtual. What about image? Real. Understood? If the object is real, image is virtual. If the object is virtual, image is real. That's enough. So now you can see object is real, image is virtual. Object is virtual, image is real. Vice versa. Vice versa. If object is real, image is virtual. If object is virtual, image is real. Understood? I hope it is very clear. Next one, plane mirror. Plane mirror, I will ask questions. If you know the answer, you can let me know. What is the magnification of the plane mirror? Anyone knows the answer? Magnification of the plane mirror. I will ask two questions. So magnification of the plane mirror is magnification of the plane mirror. Magnification of the plane mirror. Plane mirror. Plane mirror. Okay. Option A +1. Option B -1. Option C +2. Option D magnification of the plane mirror. So option D, so 0. So what is the answer? Option A, B, C. So you can mention A, B, C, D like that. So magnification of the plane mirror. What is the magnification of the plane mirror? So we can say what is the magnification of the plane mirror? That is the question. So anyone knows the answer? Let me know the answer. So I'll explain. Anyway, I'll explain the answer definitely. So question. This is the question. What is the magnification of the plane mirror? Option A, B, C, D. Anyone? Any option you can select. Any option you can select. So select any one option. Select any one option, then you'll get to know. What is the magnification of the plane mirror? Magnification of the plane mirror. Okay, fine. So it's okay, no problem. So you can understand, right? So anyway, what is the magnification of the plane mirror? So options, I'll give time. I'll count. So you can check my video, then you'll get to know. So like it's different. So depends. Virtual image. Yes. Because extended light rays are meeting, right? Extended light rays are meeting. That's why there is a virtual image. Then where extended light rays will meet? Behind the mirror. Yes. Coming to plane mirror, coming to concave mirror, coming to convex mirror, and convex lens also. Convex lens same side will get. In convex lens will get same side, last case. In convex lens will get the same side of the object. Virtual, erect and enlarge. There same side of the object will get virtual image. In concave lens same side of the object only. Okay, so except first, anyway, first case object is placed at infinity, image will form at focus because diverging. Okay, we are extending the refracted light rays, those light rays will meet at focus. And the second case, if you place the object between optic center and infinity, image will form between F and P, F and O, F and optic center and F1, yes, F1. So that time it will be virtual erect and diminish. It depends. Except convex lens and concave lens. So remaining in concave mirror, behind the mirror, virtual erect and enlarged, and convex mirror, so behind only. Okay, so where reflection is not taking place, that side only. Coming to the convex lens, so same side in sixth case, wherever object is placed, same side only virtual image will form. Okay, so it depends on lens, which lens you are taking. It depends on which mirror you consider. So in mirrors, I hope in both the cases you will get so extended light rays only, extended light rays where they will meet. It depends. Understood? I hope it is very clear. So what is the answer here? What is the magnification of the plane mirror is? What is the magnification of the plane mirror? So A, B, C, D. Which option? In plane mirror, definitely behind. So answer is A, +1. Magnification of the plane mirror is +1. So how it will be, we'll see. And one more question. So in the plane mirror, object distance is equal to image distance. So in plane mirror, okay, one can go with the so in plane, virtual image will form. Virtual image. Where virtual image will form? One is concave mirror. So option A, and coming to option B, convex mirror, and option C, convex lens, and option D, all of the above. All the above you can say, all the above. All. So which answer? What is the answer? What is the answer? So virtual image. So where do you get virtual image? So come on, answer to the questions. So option A or option B or option C. Where you can observe the virtual image. So type the answer. Option A, option B, option C or option D. Let me know the answer. Which mirror or lens forms virtual image? Only concave mirror forms virtual image? Only convex mirror forms virtual image? Only convex lens forms virtual image? Or all the above? Answer fast. Only convex lens. Okay. So I'll go for voting. So we'll see how many will say the answer. So one vote for a convex lens. So convex lens. Next one. Convex. What about remaining students? So for which one you'll go to answer? Vote for it. So convex lens, one vote. What about remaining students? So do comment fast. Answer to the question. Where did you get virtual image? Okay. So where did you get the virtual image? Answer to the question fast. So I'll be counting after 5 counts. So convex mirror. Okay, one vote for convex mirror. Next. Answer to the question. Make it fast. So I'll be counting. Ready? 1, 2, 3, 4, and last and final count 5. So all the above is the answer, because so in concave mirror last case will get virtual image. Virtual image. Okay. And the next one, convex mirror anyway it always forms virtual erect and diminished image. And the next one, convex lens also forms virtual image, where last case. So all this one will form virtual image. Concave mirror last case, convex lens last case, convex mirror. So only 2 cases are there. In the 2 cases only virtual erect and diminished image will form. Okay, all the above the answer. Understood? Next one. So one more question. I'll give. We'll see. One more question. If object is placed in concave mirror image formation, concave mirror image formation, object is placed at C. Okay, image is formed at C. So what is the nature of the image? Nature and magnification. Nature of the image. What is the nature of the image? Option A, nature of the image, and option B is magnification. 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 So what is the magnification? Answer to the questions. Concave mirror object is placed at C. Image also will form at C. What is the nature of the image? And magnification of the mirror. Answer to these questions. Do as a homework. So nature of the mirror is real and inverted, and magnification is -1. Real and inverted. Okay, so in concave mirror image will form at C. So nature of the image is real and inverted, and size of the image is same size. Okay, so magnification is -1 because same size of the object at C. Okay, thank you so much for joining. So yes, so do like, share and subscribe to Student Brand. Thank you so much. We'll see you in the next live class.